Okay, welcome everyone to my new lecture where we are going to learn about the electromagnetic force that we call Lorentz force. So this is the last lecture for magnetism, and then we are moving on to alternating currents. Okay, so for example you have a conductor and it goes from here to here, so from down to up, down to up, and there is and it is flowing through the magnetic field. And what are you going to get? You're going to experience, this conductor is going to experience some force, so it's going to move. That conductor is going to move, and this is the basic force that we use in for making electrical machines, and this is, basically the force that runs our economy, really. And now, what is the direction of that force? How do we know in which direction is the force? So, here is the left hand rule for for the inducted EMS. We use right hand. For Lorentz force or electromagnetic force, we use left hand. So here, these four fingers on the left hand are going to show the direction of the flow of the electric current. So like this. The magnetic fields the magnetic induction goes into the palm of the hand, like so, and this thumb is going to show you in which direction is this conductor here going to experience the force. So we put these four fingers in the direction of the current. Magnetic induction is going into the palm of our hands, like so, and this thumb is going to show you that the force is going to happen in the direction, in your direction, out of these black points. So, and this is the formula that we use to calculate the force, B dot times L times I, where F is the force, of course, and it's measured in newtons. L is the length of the conductor in the magnetic field. So, for example, if you have a magnetic field like this, and this little part isn't in the magnetic field, you don't calculate. You just calculate the length that is in the magnetic field. B is the magnetic induction. We already knew it's measured in Teslas. The length is, SI unit measured in meters, and I is electric current measured in amps. Okay, so let me just see. Okay, write all this down. Let's do one or two examples. So, I'm sorry if you didn't write all this down. You can pause the video clip, and then you can write all this down in your book. Okay, so for example, through a conductor there is a flow of an electric current of 40 amperes. So there is, we have a conductor, there is, a flow of electric current of 40 amperes, and that conductor is in the magnetic field where the magnetic induction is 1 Tesla. What is the force acting upon this conductor if the length of the conductor is 45 centimeters? Okay, 45 centimeters For centimeters, that's 0.45 meters. The force is equal to P times L times I. That's 1 times 40 times 0.45, and you'll get 18 newtons. Okay, so that's it. For magnetism, that's all we needed to know. This is I skipped some stuff throughout my lectures, but they are not really that important for electrical engineering. Thank you all for watching. I think when you go to high school or school, you will know. I'm, learning you the practical electrical engineering. What do you need for, when you go to work, and I think I hope I will get a lot money so I can show you some experiments that I would love to do. I would like to gain money gain money so I can do some experiments, and it will all be easier for us and for you. So I can show you how electrical engineering is done in the practical way. So thank you for watching, and we are now going to alternating currents.